Today I'll send you. I think it is available there. I can download and I'll send you. So you have any doubt? हाँ क्या
लास्ट लेक्चर को थोड़ा ब्रीफ में वो कर दीजिए।
अच्छा, तो लास्ट क्लास में क्या क्या पढ़े थे याद है? यहाँ पे है। लो
लास्ट क्लास में जो आपने कन्वर्जेंट वाले वो कराया था वो समझ नहीं आता मेरे को सही से।
कौन सा वाला लिमिट 1/n?
हाँ, वो जो कन्वर्जेंट वाले
यस
जो
सर।
करा रहे थे आप।
अच्छा, वो समझ में नहीं आया है।
नहीं।
कहाँ पे एक्चुअली दिक्कत है? प्रूफ को ओपन करो। ये सब समझ में आया है? अपर बाउंड, लोअर बाउंड,
यस सर।
सुप्रीमम, इसमें तो कोई दिक्कत नहीं होना चाहिए कि है तो बोलो।
नो सर, ये क्लियर।
अच्छा, तो तुम्हें कॉन्वर्जेंस प्रूफ में दिक्कत है तो तुम्हें यहाँ पे क्या शो करना है? लिमिट 1/, तो फिर से लिखते हैं, है ना? फिर से लिखें कि यहाँ पे बताए तुमको?
सर एक बार अलग से लिख के बता दो, 10 मिनट में।
ठीक। तो तुम्हें जब लिमिट यूज करना होगा प्रूफ में, कॉन्वर्जेंस मीन्स यू नो द लिमिट, राइट? व्हाट द सीक्वेंस कॉन्वर्जेंस। सपोज आज डेट है, you want to show limit n tends to infinity 1/n, right, equals to 0. So how will show? By via epsilon n, the definition. This definition you write, no, right? This definition you know?
Yes,
What is that definition? Just tell me. So given any arbitrary positive epsilon, right, we have to find a what we have to find? Come on, what we have to find? Given any arbitrary positive epsilon, we have to find a natural number, right? Such that for that natural number onwards, what should happen? For that natural number onwards, what should happen?
it converges to 0.
Yes, 1/n should converges to 0. So here sequence is your an 1/n and limit is 0, right? Now this you want to show less than epsilon, right? And when you show this less than epsilon, you have to show this less than epsilon for all n greater equals to some n naught. So we have to see whether this n naught exists or not, right? Is it clear?
Yes.
So this is equivalent to this one, that given any arbitrary epsilon positive, right, that exists n naught belongs to n such that for all n greater equals to n naught, this relation holds, right? That you have to show. Now to show 1/n, now to show 1/n minus 0, and n is here positive, right? Start from 1. And to show this less than epsilon, what you have to show? You have to check whether, so that means you have to show just 1/n less than epsilon or not, right? For some n equals to n naught onwards, whether you will get this relation or not, that you have to show, right? That means what you have to show? Whether via What that property I told you yesterday? Archimedean
Archimedean
property.
property. Yes, sir.
Yes. And from Archimedean property, can you write this one? So you have to show this. That means if you can show this one, and that is already you have this result from Archimedean property, right? That there exists n naught, right? There exists n naught such that this relation will hold. This is from Archimedean property. Is it clear?
Yes, sir.
Yeah. So by Archimedean property, already you know this. Now you have to choose the integer n greater equals to n naught, right? So by Archimedean property, there exists one n naught such that this relation hold. Now you have to choose n for any n greater equals to n naught. So you have to see the tail of the sequence. You have to see the tail of the sequence what will happen for the tail of the sequence in order to check the convergence, right? It does not matter where the first n naught elements will goes. First one element, second element in the sequence up to n naught element in the sequence. What will happen? We don't care. We only care about the tail of the sequence. What will go from after some n naught onwards, right? So now we have to show that for any arbitrary epsilon positive, we have to show that this is just 1 by n, and that is your 1 by n naught, right? Here, and then that is your less than epsilon by Archimedean property. So you have that this definition given in arbitrary. So you have found here one n naught belongs to n such that for n greater equals to n naught you have found it. So via these two things you have proved it. So this epsilon is here arbitrary. Is it clear or you have still doubt?
Yes, sir. Not it, no.
So for when you say that the sequence convergence, that means what will happen for the tail of the sequence, right? For some n naught onwards, what will happen? Not for first few terms, what will happen? We don't care about that. What will happen after some n naught onwards? Yes, Yuvraj, you have any doubt? Yuvraj Singh?
No, sir. No, sir.
Okay. So what is happening for the tail of the sequence? Then you have studied that real number, one property of the real number, that is, what is that property?
Completeness.
Huh?
Completeness property.
Yeah, completeness property you have studied, right? Then supremum, infimum, and upper bound, least upper bound or supremum, and greatest lower bound or infimum. And if they belongs to the set, then supremum is known as your
Oh. Least of
supremum. No, supremum is least upper bound. And if that supremum, the least upper bound belongs to the set S itself, then supremum is known as your
Maximum.
maximum. That means
Maximum of S.
yes, that means supremum is attained. Okay, supremum is attained, meaning that maximum. Okay, supremum or infimum is attained. Is attained means the supremum and infimum of the set belongs to the set S itself. So supremum will same as your maximum and infimum is same as your minimum. This is okay. And you know that M is the supremum of the some set S. What do you mean by that? That you also know, right? What do you mean by that? That all the element of the set S is lesser equals to suppose here all these elements of this set belongs. Okay. So what will happen? So supremum is like here, suppose. Yeah. So all the set of this set is lesser equals to lesser equals to capital M, right?
or capital.
And now if you take some smaller number less than M, what will happen? if you take some smaller number less than m, then what will happen?
Fall inside the set.
Yeah, that means you will get one element from the set S such that m minus epsilon less than. So ys means this element from this set, y epsilon, and f means this depends on the epsilon. Okay. So given any epsilon positive, there exists one y in the set S such that, so if you take some smaller value than the supremum, then you will get one element from the set. But this one element belongs to the set, okay? Which will be greater than this value m minus epsilon. So even if you take small values epsilon and if you subtract from m, then one element will be greater than this element. Similarly for the infimum also. Suppose here m is infimum. Similarly, if you add some number with the infimum, then there will be one element from the set. Is it clear? Suppose we call it some another y1. Is it clear? So
Yes.
x is greater or equals to m for this is for infimum and this is for supremum. Okay. This you have studied in the last class. Then you have studied also density properties between two any real number. There exists one rational, there exists one irrational number in between there, right? For any two arbitrary real numbers, there exists one rational, there exists one irrational number in between them. What other properties you know? That algebraic properties of the real number in the first class you have studied. Order properties also you have studied. And I told you that all these things you can prove on your own. Some basic properties. Maybe it looks like trivial, but it is not. Okay. So if you know all the algebraic properties, you can prove various properties. Then also in the last class, I told you another property that is which will be used maybe again and again later on. That if A belongs to R such that 0 less equals to A less than epsilon for every epsilon, then you can prove that A equals to 0. And this will be proved in various limit proof, sequence proof, and also continuous functions proof. Various epsilon, delta, epsilon n proof, you will use always this kind of thing. For any arbitrary epsilon, suppose 1 by n less than epsilon, that means that 1 by n goes to 0. And A is here 1 minus n minus 0. Right? So this kind of things you can always prove from the properties of the real number. Okay?
So in exams, proof will also be coming.
So if its proof is like very trivial, just tricks you have to use some. If the proof is lengthy, it will not come in the exam. Okay. But
Okay,
if there
sir.
is some little bit tricks, okay, little bit just you have to some construct something and you will get the proof. Suppose it can come that whether limit n tends to infinity 1 by n goes to 0. So by epsilon n definition. Okay.
Okay, sir.
Do you have any other question till now? Any question from anyone? Is it clear to all of you till now, whatever we have studied?
Sir,
Suppose we,
I was searching for some problems to solve based on the things that you've taught till now in the book Thomas Calculus. So, in which chapter we'll be finding the problems?
So you just check properties of the real numbers and then just check the sequence. So either from the Thomas book, and then I also told the Battle Server book, right? Real analysis.
Yes, sir.
Maybe in real analysis, I know that Battle Server book, there is a chapter called real number. Okay, some part of it you will get it. There is a big chapter for real number. So whatever you have studied, there you will get lot of exercise problem also. And but we will send you the tutorial sheet. Okay.
Okay, sir.
For additional study, you can look at the books. Okay, in the reference book. And today also, last time I show you the syllabus. Today I'll send you via mail also. Okay. Last time you have seen the syllabus, right?
Yes, sir.
and all the reference book, but still I will send you the in email, okay, all the details lecture to this today. Tonight I will send you all this. Suppose we take, okay, let me continue. N by n plus 1. And where this sequential converts? This sequential converts to which value? Suppose we have to show that sequence converts, and but you can guess first the limit, right? If you want to use the epsilon in definition, first you have to guess the limit, right? Like in limit epsilon delta definition, first you have to guess the limit where the function will go. So this sequential converts to, come on, tell me. So you have to first guess the limit, right? So the sequential converts to, then we'll show by epsilon in definition. So the sequential converts to, okay, let me see whether I am recording it or not. One second, huh?
Slam.
Hmm? Is this recording is continuing?
Recording in progress.
Okay, so okay. Okay, so tell me, what the sequential converts? Maybe the first whatever I have revised for the last 2 lectures, maybe it is not in the recording. Okay, I just start recording. So tell me, in order to show by epsilon n definition, first you have to guess the limit of the sequence, right? And what is your guess? This sequential converts to? This sequential converts to? Anyone? Yes, many Ayush Kumar Singh. Yes, 1. So you just inform, okay? You don't need to write in chat. Okay? You just tell me unmuting and chat tell that. Okay, so how you know that the sequential converts to 1? You can check in many ways, right? If you divide it by n, suppose roughly, then it will be 1 by n, and 1 by n goes to 0, you know. So that means the limit will goes to 1. Or you can check this one, n plus 1 minus 1 by n plus 1. That means 1 minus 1 by n plus 1. Okay, and you know the sequence 1 by n goes to 0. So 1 by n plus 1 will also goes to 0. Okay, so this will converge to where now? 1. So how will show that this will converge to 1? So what I have to do? This is your sequence and this is your limit, right? So this will ultimately converge to 1, that you know. So we have written mod of an minus l, given any arbitrary epsilon positive. So what is this sequence? This is nothing but your n by n plus 1 minus. So ultimately you will get 1 by n plus 1, right? This is clear up till now. So we have found this one, right? 1 by n plus 1. Now this should be less than. Now this should be less than. Tell me.
1.
No.
1.
Why this should be less than 1? This should be less than. We have to use the
Epsilon.
epsilon in. Yes, we have to use this definition. That means this should less than epsilon, right? And for that you have to find one n naught such that So given epsilon positive, we have to find this one. This n naught we have to find. Okay, so what will be the n naught? Can anybody tell me? So you can you can back calculate from here, right? So this is your less than epsilon, right? This is clear. This should be your less than epsilon, right? So that means what n you should choose? Huh? So from Archimedean property, this you already know, right? From Archimedean property, this you already know. You know or not? Hello.
Yes, sir.
Yeah, this you
Yes,
know,
sir.
right? Now tell
Yes,
me
sir.
what will be the relation between n and n naught. Now tell me what will be the relation between n and n naught. You have to see from some n naught onwards whether this relation holds or not, right? So from here you can see what will be the relation between n naught and n. What?
N naught equals to n plus 1.
That means for any n greater equals to n naught minus 1. Okay. Is it clear?
Yes, sir.
So so you have to show that for any arbitrary positive epsilon, you have got this. Now if we choose n naught such that for all, so 1 by n plus 1 will be lesser equals to 1 by n plus 1. Here you can write, right? N plus 1 is greater equals to n naught, and 1 by n plus 1 greater equals to 1 by n naught. That means you have got 1 by n naught. And from by Archimedean property, this is less than epsilon that you want to show, right? So we have shown that given any arbitrary positive epsilon, there exists. So we can write that given any arbitrary positive epsilon, there exists n naught such that for all n greater equals to n naught minus 1, n by n plus 1 minus 1 less than epsilon. Is it clear? Everybody, you should not have any doubt in your mind whether epsilon is this or that, whether n what is n. So you know what you have to show. N minus L less than epsilon, that you have to show. Via showing in between you will get relation between n and n naught. Okay. And this Archimedean property that the n naught and what will be the relation between epsilon. Okay. Is it clear now? For any kind of proof, for any sequence, now you can check what will be the, how will prove the convergence using epsilon n. Alok Yadav, is it clear to you?
Yes, sir.
Okay. So now similarly, we can write one definition of bounded sequence. So what do we mean by bounded sequence? So what do we mean by bounded sequence? Suppose n greater equals to 1 is a sequence. Now when you say that is, so what do you mean by bounded sequence? So earlier you have seen that suppose for a set, what do you mean by bounded? Bounded above, bounded below, you have seen, right? Similarly, same definition. So tell me, suppose first n is bounded above, okay? Whatever you have studied, similar version you can study it for sequence. Whatever you have studied for function, continuous function, similarly for sequence. Many things are similar. Only one is in continuous case, another one is like discrete case. So sequence is like discrete case. Okay, because the mapping is from natural number, right, to some field, either R or C. So this is like discrete. It has many gaps. Oh, it will start 1, 2, 3. At this point, what will happen with the function f? So f of n is like your an. Is it clear?
Yes, sir.
So an is bounded above. So when we say that this sequence is bounded above, if similar definition, whatever you have studied in the set of real numbers, subset of real numbers, the set, tell me if when we will say that an is bounded above? If there exists, if for some alpha n is lesser or equals to alpha for all n, okay, then an is said to be bounded above. Is it clear? Whatever you have studied in the set, subset of real number definition, the set is bounded above. Same definition, okay? Similarly, n is said to be bounded below when? When? Tell me, if for some beta, what will happen?
an greater than equal to beta for all
Yes.
beta.
For all n.
N.
Yes. And then we'll say that an is bounded if it is both bounded above or bounded below, okay? That means in the all the elements of the sequence will bound. So here it is like your alpha. This all the elements of, and here it is your beta. In between n elements of n should be like, okay? So n is bounded if it is both bounded above and bounded below. Okay, now it is clear.
Yes, sir.
So can you give one example where the sequence is bounded? Can you give some example? Can you give some example of bounded sequence and one unbounded sequence? Why it is taking so much time? Can you give one example of bounded sequence? Is it so tough? So you have to see whether all the elements of that sequence is both greater equals to and lesser equals to some value. So it will lies between two number, fixed number.
One by n.
Yes, 1 by n, right? Some other example, so you can check. 1 by n, okay? Minus 1 2 by n square. So suppose this sequence 2 to the power n by n square, okay? So this is bounded or not? This one? Bounded or not? What do you think? 2 to the power n by n square, this should be bounded or not? Can you check? This is the exercise. If you cannot check, you can try. Okay?
No, sir.
Huh?
Sir, when we put n is equals to 4, it comes 1.
And then for n equals to 5,
Sir, it is greater than 1.
so what will happen? That means what is happening if you take n equals to 6, suppose. That means what is happening?
So it is not bounded.
Yes, it is not bounded, right? That means whatever you are saying is correct. 2 to the power n is greater than n square, right? So from n greater, so n square is greater than n. From 5 onwards, right? You are saying. So from here you can see that 2 to the power n by n square is strictly greater than 1 and it is increasing. So you have seen convergence sequence, right? You have seen convergence sequence and bounded sequence. So what will be the relation between them? If n converges, then it is bounded. That you can prove. Okay, if a sequence converges, then it is bounded. So how will prove it? If a sequence n converges, then it is bounded. How will prove it? So suppose limit n tends to infinity, n equals to L. Okay, so this converges to L, the sequence. Now you have to show that this n is bounded. How will prove it? What will be the proof? Can anyone guess? So you have to see these two alpha beta such that you will get this kind of relation, right? Then we will say that this sequence is bounded. Is it clear? Is it clear or not?
Clear, sir.
So how will find I'll find this a alpha and beta. कौन है
रोटी
अखिलेश?
तोड़ रही हो घर में बैठ के और जाओ बर्तन धुला
ये कौन है अखिलेश साहू FC? रोटी मोटी क्या पता नहीं क्या क्या बोल रहे हो. So how will get this alpha and beta? So what is the meaning of this relation? That given any arbitrary positive epsilon, any arbitrary positive epsilon, you can find one n naught, right? Such that for all n greater equals to n naught, n minus l less than epsilon. So you can choose, because it already says, we have already assumed that this convergence, right? We have already assumed that this converges. Now you have to show bounded. That means from the convergence property, you can choose epsilon 1. So this relation holds for all n greater equals to n naught. Is this clear or not? Because it is already given that this sequence converges to L. That means this is clear. Everybody? Everybody, this is clear or not?
Yes, sir.
Yes. So now what you have to do? Now what you have to do? So what will be your now alpha and what will be your beta? Can anyone tell me? What do you choose alpha?
L plus 1.
L plus 1 and so this relation you have to check like for every n, right? For n greater equals to 1. Okay, you want to see that what is happening. Okay, so you have to also see what is happening also before n naught, right? Till n naught, what is happening? So what we choose? Alpha, L plus 1 and what you should choose? You have got it, what you have to choose? And beta, what you should choose? Can anyone guess what you should choose? What are the other elements? For if you want to consider for all n, then what is A1, A2, A, n naught minus 1. What you should choose? Can anybody tell me? What we should choose? What we should choose here? What we should choose here? Anybody has written in the chat something? What we should choose? Alpha as?
Sir, L plus 1.
No. That is L plus 1 for n equals to n not onwards, right?
Yes, sir.
Before that also all these numbers are there, right? So what should we choose? Alpha as a? Tell me. What we should choose? Alpha as? We have not got it. Suppose we have got here. Suppose L minus 1 is there. Okay, L plus 1 is there. And this relation holds for n, for all n greater or equals to n naught, right? Now you want to see what is happening for all n less than n naught. Then you have to see which one is for beta, which you have to see. All these numbers you have to see, and then L minus 1, and then what you have to see here? Why you are not getting? What we should choose here? Maximum. And here minimum. So all these elements A1, A2 up to n naught minus 1, and then for n naught onwards this relation holds. So for n before n naught, what is happening? These are the numbers. Then you have to check maximum of all these numbers and minimum also of these numbers. So you have already got beta and alpha. So you can write now. This is for all n greater or equals to n naught, right? Now we want this for all n greater or equals to a. Is it clear? So every convergence sequence is bounded. Okay, that means every convergence sequence is bounded. So proof is completed here. So now what about the converse? What about converse? If suppose some sequence is bounded, that does mean that the sequence converges. Can you give one example? What about converse? Suppose some sequence is bounded. Does that mean the sequence will also converge? For convergence, this L should be unique, right? Can we have some sequence? Suppose for odd term, it will converge to some number. For even term, the sequence will converge to some other numbers. But the sequence can be bounded. Can you give some example? The basic example, trivial example. Minus 1 to the power n. Okay. What will be the first element? What will be the first element?
Minus 1.
Yes, second element 1. Okay.
1.
Third element minus 1. That means odd term will goes to odd term is like minus 1, right? And even term is like 1. So does this sequence bounded? Does this sequence bounded?
No, sir.
Huh? No. Is this sequence bounded or not?
Yes, sir. It is bounded.
Yes, sir. Yes, sir.
It's bounded,
Yeah.
sir.
So it is bound. Its lower bound is?
Sir, minus 1.
Yes, and upper bound is 1. Right? Does this sequence converges to some real number?
No, sir.
Yes. So this is the
Minus
example
half.
that is bounded but How will prove that the sequence not converges?
Sir, it is not attaining a particular value.
But
Yeah,
with
so
the-
you can use epsilon in definition. Okay, this is your exercise to show that this sequence is not convergent using epsilon in definition. Okay, everybody, is this clear that you have to show this sequence is not convergent? That means this sequence does not converge to a fixed real number. You will not get unique real number. It should be right. Okay.
Yes, sir.
So suppose two sequences are there and you note their limit. Okay. Now what do we mean by algebra of limits? Suppose limit n tends to infinity, xn is x. Another sequence yn, similarly, its limit is y. Now what do you mean by algebra of limits? Like in limits you have studied, right? Similarly here for sequence also. So we know that given to convergence sequence, xn and yn. Okay. We know that there are two sequences xn is yn and xn converges to x and yn converges to x. From there you can prove using this epsilon n definition that xn plus yn is also converges and it converges to is convergent and is converges to where? Whatever you have studied in limit, same here. Okay. Similarly for xn minus yn. Okay. Here xn minus yn. Limit is there. Similarly for product also. Okay. You can prove it. Where this denominator is non-zero. Xn by yn also. So if y not equals to 0, okay, suppose xn by yn is defined for all n greater or equals to some n1 onward, suppose. Then this its limits is convergent and limit x and yn x by y. So have you studied sandwich theorem before?
Yes, sir.
Yes,
Yeah.
sir.
What is, yeah, so
Yes,
for
sir.
sequence also similarly sandwich theorem will come. Okay. So what do you mean by sandwich theorem? Can anyone guess? Three sequences there, okay?
Like similarly, like if we have to check for sequence B, we'll check for sequence A and C where they converge, and
Yes.
similarly we'll conclude that sequence B will converge at that point, at that number.
Yeah, that is why the is named sandwich. Also, you will see some squeeze theorem also in some book. So three sequences are there. Okay. Suppose the middle one you take like lies between these two sequence values for all n belongs to n, and both the first and the third sequence converges to the same value L. Then from here you can conclude that limit n tends to infinity, Bn should also converges to L. That is known as your sandwich theorem. This you have studied in limit, right? So now using that property, you can prove it for various values of what will be the values of this. Okay, so suppose it's not always possible to check this epsilon and definition. Maybe it will be lengthy for different. Suppose rational function type of sequence are there. If you use epsilon, maybe it will be cumbersome, right? So you can use various properties of the sequence, algebraic properties and other properties also. So suppose this is the sequence, then where it will converge? Suppose Bn is like sin n by n square. Okay. So then why it will converge? By sandwich theorem, if you want to apply. How will apply this sandwich theorem? So you have to find two sequence, right? An and Cn, where this Bn lies. So what will be your An? What will be your An? What will be your An?
Sir, n upon n plus 1.
Oh, this is just non-negative sequence, right? So n can be your zero sequence, right? Is not it? And this is lesser equals to
1.
huh?
1.
1. That means you have to find one sequence. This sin n is lesser equals to 1, right? So this is, so now you have got two sequence, this An and Cn. Is it clear now?
Yes, sir.
So here you will get one sequence and here you will get another sequence. Okay. And members of the sequence are An is 0 and Cn is 1 by n. So by Sandwich theorem, limit n tends to infinity, Bn is 0. Okay.
Sir, how did you guess Cn is equals to 1 by n?
I have not guessed, I have proved it here. So this is always lesser equals to 1 or not, sin n.
Yes, sir.
Mm.
Yes, sir.
So that means this is lesser equals to 1 by n square. Even also you
Yes,
can
sir.
choose Cn equals to 1 by n square. Okay, that you also can prove
By
that
sandwich
1 by
theorem.
n square, yes, 1 by n square. But we have, you know that, right? N square is always greater or equals to n for all n natural number, right? So this relation is holds. Either you can choose this one also, but since we have already shown that if you choose Cn 1 by n, that goes to 0. That we have shown, right? So you have choose Cn. So it lies between two sequence, this Bn, either one is 0 and another is 1 by n. And both you know that converges to 0. That we have already shown. Okay. So we have proved it here, not assume anything. Similarly, how much time I have? So you have already studied completeness property of the real number, right? Here we will study in terms of sequence. Okay. So suppose n is, so some definition is needed, monotonically increasing. Okay. So suppose n is said to be monotonically increasing. When you say that n is said to be monotonically increasing, what is your basic, what should I write? That n is said to be monotonically increasing if n plus 1 lesser equals to an. for all n greater equals to 1. Okay, then we will say that this sequence is monotonically increasing. Okay, similarly n is said to be monotonically decreasing. If an plus 1 lesser equals to an for all n greater equals to 1. Okay, so can you give some example of monotonically increasing sequence and monotonically decreasing sequence? Till now what you have studied, from there you can say. What about this sequence n?
Sir, monotonically increasing.
Yes, and is it bounded above?
No, sir.
Okay, so why I am talking about also bounded above? Because maybe in next class we will see if some sequence is monotonically increasing and bounded above, what will happen? If some sequence is monotonically decreasing and bounded below, what will happen? Okay, so this is monotonically increasing and not
Increasing.
bounded
Bounded.
above. Okay, what about
And
this
sir, 1 by
sequence?
n.
What about this
1 by n,
sequence?
sir, monotonically decreasing.
Monotonically decreasing. Is this bounded
Decreasing.
below?
Yes, sir.
Bounded
No, no,
below
sir,
by?
no, sir, no, sir.
No.
Ek minute. Sir, bounded below, sir.
By which number?
Sir, 1.
Even 0, right? Is not it? This is 1 by n, right? 1 half.
Yes, sir, yes, sir.
Not 1, right? 1 half, 1
Yes,
by
sir, yes,
3,
sir.
1 by 4. All these
1
members
by 3,
are
yes, sir.
greater than 0 because, right?
Yes, sir. Yes, sir, yes, sir.
So what about this sequence? Minus 1 to the power n.
सर सर इसको कुछ नहीं कह सकते सर, इंक्रीजिंग नहीं डिक्रीजिंग नहीं सर.
Yes, so is neither mi nor di. Okay, so we'll continue here in the next class. Okay, what do you mean by completeness property using this sequence? That if a sequence is monotonically increasing and bounded above, what will happen?
Sir, sir.
Yes.
Sir, which book we have to follow?
So I told you already, right? There are many books. Many engineering books are there for calculus courses are available.
For this chapter, sir, for this chapter.
Huh?
Sir, for this chapter.
Okay, so you can either check a Bartel-Servat also, this sequence, okay, and real numbers also you'll get in the Bartel-Servat book and also Thomas calculus book, okay.
Sir, Thomas calculus chapter नहीं है real number.
Okay, real number you can study from this Bartel-Servat book, okay, that is chapter for the real number system. It is written beautifully.
Sir, book का नाम sir वो समझ में नहीं आ रहा.
Real analysis by Bartel and Servat. I'll also send you the syllabus, okay? If you have not seen in the last class, last week. Okay. Real analysis. Real analysis by you can search, huh? Google you will get Bartel and Servat. This is the age, huh? Okay. We'll continue here in the next class. Otherwise, it will maybe someone will log in some other faculties. You have some class maybe, right?
Yes, sir.
Okay.
Thank you, sir.
Okay. Bye. You can now
Thank you,
log
sir.
out.
Recording stopped.